Hi, we're going to investigate a machine that swallows your money mathematically. One of the outcomes will be a very famous mathematical sequence. Let's investigate. The money machine. Let's suppose you come across a mathematics money machine, and these are the instructions you read on the outside. It says, I will give you 1 point to start with. How very generous. And if you insert 1 coin, I will add 2 points to your total, and if you insert 2 coins, I will double your score. And you must use all of your coins if you're going to have a chance of winning. Unusual instructions. Let's investigate some possibilities of using different numbers of coins. Let's have a look to see what the situation is with some combination of coins. Starting with 1 coin, we start with 1 point, remember? And there it is. 1 coin, there's only one way of inserting that into the machine, and we get 3 points because we already have 1 point, and we get 2 extra points for using 1 coin. The pink number 1 there on top of the coin is to let us know that 1 coin was inserted. With 2 coins, there's one way of inserting the coins, 1 coin each. That would give us a total of 5 points, because we get 2 points for each coin we insert. Or we can insert both coins at the same time, and that means our score is double. So we started with 1 point. If we double that, we get 2 points. Are there any other ways of inserting 2 coins? No, there isn't. 3 coins. There are 3 combinations. There they are. The first combination of inserting 2 coins and then 1 coin gives us 4 points. The second combination, putting in 1 coin followed by 2 coins at the same time, gives us a total of 6 points. And the third way is to insert 3 coins one at a time to give us a total of 7 points. So the maximum number of points possible is 7. And we can continue in this way. Let's just see a couple more. 4 coins, 5 combinations, a maximum of 10 points. 5 coins, 8 combinations, maximum of 14 points. 6 coins, 13 combinations, maximum of 20 points. 7 coins, 21 combinations with a maximum of 28, and so on. We can summarise the results up to 12 coins as shown on the screen. Have you noticed any pattern in the combination of numbers, in the combination of coins, or in the total score possible? We can investigate each of those situations. Now here's a summary of the combinations up to 12 coins. And the sequence of numbers given for the number of combinations possible is 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, and 233. Do those numbers ring a bell? Have you met them anywhere else? They define a very famous number sequence. There's the first combination for 1 coin, 1. Second combination, 2 ways. Third combination, 3 ways, and we can write that as 2 plus 1. Using 4 coins, there are 5 ways, and we can write that as 3 plus 2. With 5 coins, 8 ways, we can write that as 5 plus 3. Can you see what's happening? Each combination can be found by adding the 2 previous combinations, and that defines our very famous number sequence. Yes, it's the Fibonacci number sequence. Very well known. It appears in nature in many different ways. Now, is there a pattern in the maximum score possible for using different numbers of coins? There's a summary, again up to 12 coins, And you can see there the maximum scores possible, 3, 5, 7, 10 and so on. Do you think there's any sort of pattern in those results? If you think about it long and hard, there is. Let's look at the even numbered scores first. There they are. 5, 10, 20, 40, 80 and 160. What's the pattern there? Well, if you said they double each time, you're exactly right. What about the odd numbered scores? And this time we have to be a bit selective. The odd numbered scores starting from 3 coins. And there they are, 7, 14, 28, 56 and 112. What do you think the pattern is there? Again, we are doubling each time. Finally, let's look at what sequence of coins is required to obtain the maximum score. And there's a summary of that. For 1 coin, there's only one way of doing that, of course. We insert a single coin. For 2 coins, the maximum score is obtained by inserting each coin separately. For 3 coins, the maximum is obtained by inserting 3 coins separately, and so on. Can you summarize those results? Again, we can look at even and odd numbered coins being used. Even numbered, that's the sequence of coins needed to obtain the maximum score. Can you describe what's happening? Perhaps you might say that you must use 2 coins separately to begin with each time, and after that you use 2 coins at a time. What about the odd numbered? Again, we have to be a bit selective. We will start with the odd numbered starting from 2 coins, and they're the sequence of coins needed. Can we describe what's happening there? We can say that we need 3 single coins inserted to begin with, and then followed by using 2 coins at a time. I hope this gave you some appreciation of this sort of problem solving involving yet another look at the famous Fibonacci sequence, and a bit of algebra and a bit of number sequence pattern recognition. Until next time, bye bye.